Now we're going to talk about one of the most important tools that we have in the second half of the semester, and that's a free body diagram. So, remember we use vectors a lot in the first part of the semester, and we're going to continue to use vectors. You can't do physics without vectors, and as you take higher level classes, they become increasingly important. But we're also going to see that we can't really talk about the motion of an object very well without being able to sum the forces properly. And the best way to do that, that I've found, and that's most commonly taught, is the use of free body diagrams. Okay, so I think the best way to talk about a free body diagram is just by an example. So let's look at the example of a ball rolling down the hill. So we'd probably be given some picture like this. So we'd have an inclined plane. We'd be given some angle theta, and we'll be given a ball that's rolling down the plane. Okay, so a free body diagram, what we would do is we take the ball that we had there and we just draw a picture of our ball. A lot of times I just draw my free body diagram right on the picture, and that's fine too. So remember, here we're saying that it's rolling down with some velocity v. But in the free body diagram, the first thing we do is we draw the object. The next thing we do is we pick a force. So first we'll say the force of gravity. So we're going to say the force of gravity is going to act on the center of mass, and it's going to be going downward. So we draw a dot where the force is acting, and then we draw an arrow in the direction representing the force. So over here on our drawing, that's just saying the force of gravity is down, and we make sure to label it so we know what the force is. Okay, but that's not the only force. We also have a force of friction that's right here between the ball and the ramp. So we have another dot there, and we have the force of friction, that's going back in the direction of the ramp. We also have a drag force, and don't worry. We're in the next couple of videos we're going to talk about all these forces more in detail. Right for now we're just showing. I'm just showing you an example of how you would set this up once you understand which forces to apply. So we would have a drag force that's being applied to the front of the ball, and this is from all of the air that's going to be hitting it. So over here in our free body diagram, we have the drag force, and then we also have a normal force, because the ball isn't rolling through down, isn't falling through the ramp. So we have a normal force coming at the top. Okay, so this would be our free body diagram of the ball, and then I'm going to show it graphically, but of course we would actually use this in terms of equations to figure this out. But we add together all of the forces, and if I did it properly, which I haven't here, so if I drew them all correctly, then I would have had, I'd have some net force that's going in the direction of down the ramp. So this would be, what it should look like if I had drawn everything correctly. Okay, so in the next several videos, we're going to actually start taking a look at, these specific forces that we've labeled on here. Your book talks a little bit about, different categories of forces and where all of the forces fit into those categories. And so I recommended that you read that so you can understand this better. But what I'm going to do is I'm just going to be showing you more functionally, like how we take these forces that your book talks about and apply them to free body diagrams.